Now I used F for both of these fields, so, you know, obviously you can calculate the divergence for this one and for this one, right? Or for this one and for this one. I probably should have distinguished them, but, okay, the divergence of the xi plus yj field is the del operator dotted with xi plus yj, which is partial of x with respect to x plus partial y with respect to y, which is 2, right? Okay? And you apparently got that, because when I walked in after stepping out for a drink, I said, did you get 2? He said, yeah. Okay? And you wouldn't have gotten 2, I don't think, unless you've done this. Anyhow, that's how it's done. It's a very simple mechanical process. You just write down what it is. Del dot F, right? And let's do the, I'll do the curl of the same field. Okay, so there's the cross product, right? Which means it's a partial of x with respect to x times I cross I, just using the distributive law, which is really the most fundamental way to understand it. And you can use the determinant thing too, which is really kind of easier, especially since you only have 2 components here, to just do the distributive law, because you only end up with 2 components, and they're both going to be k's. Okay? And you see why it happens. Because you understand that I cross I is 0 if you understand what a cross product is. And then it's going to be the partial of x with respect to y times I cross j. And of course, I cross j is k. You don't have to have a magical formula. You don't have to remember the formal definition, this minus this times I plus this partial minus this partial times j, and all that stuff. The general definition, the cross product that's usually given, right? I prefer just to define it in terms of distributive law, because we know how I and j and k articulate by the right-hand rule. Okay? And anyhow, it's going to be then plus partial of x with respect to y times j cross I plus a partial of y with respect to that is partial of x with respect to y. I think I wrote it down wrong. Partial of y with respect to y times j cross j. Okay? Well, I cross I and j cross j are both 0. Partial of x with respect to y is 0. Partial of x with respect to y is 0, and looks like I wrote it down wrong. So I distributed this way, and then I distributed this way, and I got confused about how I distributed. Not really. Anyhow, partial of x with respect to y is 0. Partial of x with respect to y is 0. I should have gotten
your second term.
Partial of x with respect to y times j cross I there, and partial with respect to x of xi.
I think your second term should be
I don't know, something's wrong
dy,
with 0.
dy.
And it's a vector, okay? I wrote something down wrong here. And just plain old bookkeeping ignorance. Let's see, I'm doing the partial with respect to y of x, right? Then I need to do the partial with respect to y of y. That'd be j cross j. sorry, okay, partial with respect to I of this.
You're taking the partial
You know,
of x
I'm
three times.
just not seeing, I did something that was wrong, and now I can't get my brain out of it, but fix it. It's simple, it's trivial. Everything is zero. Okay, either you have I cross I, or you have J cross J, or you have partial with respect to X, partial of Y with respect to X, I cross J,
Oh, the curl is not
and yeah,
2x plus 2x 2y. It's
yeah, that should have been partial of Y with respect to X,
okay, there you
okay? And then partial of X with respect to Y times J cross I, and there it is, okay? I think that's right, but it's all zero. And it's very simple, it's trivial. Okay? Except that in doing this, I mixed up the way I was doing the distributive law, which is just a stupid thing that you wouldn't do, especially if you write out every step, okay? You know, to avoid that, you would write a partial of that with respect to X, I, crossed with all this, partial with respect to Y times J, crossed with all this, and don't skip a step like I did and got messed up, okay? Now, if we look at this field, is this field diverging or is it rotating or curling?
Diverge.
It's diverging and there's no rotation, there's no curl. If you have these force vectors acting on that disk, what's going to happen? Nothing, because every vector has its opposite, right? Your net force is zero, your net torque is zero. No vector creates any torque because the vectors are all parallel to the moment arm vector, okay? So there's no rotation. All those ideas in context, right? But there is divergence, because this thing is getting pulled apart. At least it's being stressed. Okay? So you want those connections. Now let's go ahead and calculate these. Calculate the divergence and curl of this field and see what you get.